For our third example, we're going to use the third type, and you can see it right here because it's x squared minus a squared. So a squared is 36, which means a must be equal to 6. So it's this substitution right here. All right, so that means that the secant of theta is going to be x over a, so x over 6. Or we can think of it as the cosine of theta is 6 over x, tomato, tomato, right? It's fine either way. All right, and we know we're going to have to section off a whole bunch of work here. So I might as well get started on doing that. So that's the way trig substitution problems work. You have all your work for your substitution over here, and then you have all your integration and calculus over here. Okay, so let's see here. I'm going to make a triangle. It's a beautiful triangle, and it has an angle theta in it. I know the cosine of theta is 6 over x. So this side right here is 6, and the hypotenuse is x. And then I can use the Pythagorean theorem to find the other side, right? Because if I call this side b, for example, 6 squared plus b squared must be equal to x squared. So b squared is equal to x squared minus 36. So b is equal to the square root of x squared minus 36, which is right here. And again, you could have found it by memorizing the triangle that comes with the trig substitution, but you don't need to memorize it. As long as you have this pit right here, which I forgot to actually box this in, but it's the most important part. So I like to kind of give it a box and make sure that it's really noted that that's the substitution I'm making. Then everything else will fall from that substitution. So here's the triangle that I can build from that substitution. Then I can solve this for x and for theta and for dx, which those are the typical pieces I need. So let me write those. So x would be equal to 6 divided by cosine, or in other words, 6 secant of theta, right? So 6 secant of theta, or 6 divided by the cosine of theta. You never know which one's going to be more useful. I imagine the secant one's the one we're going to use, but just in case, there's the 6 over cosine piece. Dx is the derivative of secant, which would be 6 secant theta tangent theta d theta. We know we're going to need this piece right off the bat. I mean, we know we're going to need x, and we know we're going to need dx. I mean, that just goes without saying, because those are the pieces that we always need for this substitution. At least it has been so far. Theta would be the arc cosine of 6 over x. I mean, if you look back here, theta is the arc secant of x over 6, or the arc cosine of 6 over x, whichever way you like. So theta is the arc secant of x over 6, but that's the same thing as the arc cosine of 6 over x. With any luck, we won't need to use it, but there you have it. All right, we can stop right there. If we need anything more, we'll come back, right? Because, of course, we could need the sine of theta or the, tangent of theta or whatever, and we can build all of it from our triangle. All right, let's go back to our integral. So for our integral, I won't forget my integral sign this time. All right, so it's x squared. X was 6 secant of theta squared minus 36. And all of that is raised to the -3/2 power. And then for dx, I'm going to write 6 secant theta tangent theta d theta. It's amazing, isn't it? All right, so here's the x substitution right there. And then this is the dx substitution, right? Which I starred just to kind of help us keep in mind what we're doing. I know it seems crazy. That doesn't seem any easier, but it is. It will be, I promise. Well, maybe not easier, but it's doable. The original problem is not possible. This will be possible with a lot of algebra, trig, and, well, elbow grease. Okay, so a couple things. I noticed there's a 6 right here, so I'm going to pull that 6 out in front of the integral, just for the sake of it. And then I also notice 6 squared and 36. That means that there's a 36 inside there. So I'm going to factor that out. Oop, wrong pen. So I'm going to say 36 times, and then it's, oh my goodness, I lost a C on my secant. There it is. All right, secant of theta squared. Well, secant squared theta. I don't even need a parentheses, minus 1. And that's all to the negative 3 halves. And then there's a secant theta, tangent theta, d theta sitting out here. All right, so all I did was factor out a 36 because 6 squared is 36 and that's 36, so I factored that out. And then I can find what 36 to the negative 3 halves power is. Matter of fact, I can do it in my head. The square root, because the divided by 2 is the square root of 6, or excuse me, the square root of 36, which is 6. And then 6 is raised to the negative 3 power, which means it's 1 over 6 cubed. So I have a 6 here, and this number right here, raised to that power, will become 6 to the third down here, right? 6 because it's the square root of 36, and it's in the denominator because the power is negative. And that leaves me secant squared theta minus 1. And if you're like me, that should be setting off little bells in your head because that's a Pythagorean identity. We know what secant squared theta minus 1 is. It's tangent squared theta. So I'm doing several things at once. I factored the 36, and then I took 36 to the negative 3 halves, which got me here. I didn't actually finish it out, but I will. And then tangent squared to the negative 3 halves, right? And then times secant theta, tangent theta, d theta. I haven't done anything with any of that. So I'm messing around inside this bracket here, which is technically a square root in the denominator raised to a third power, but it's not necessary to write it like that. So I factored the 36 because 6 and 6, 36. Bring that out because 36 to the negative 3 halves comes right here. And then this has a Pythagorean identity. That's tangent squared. But it's tangent squared to the negative 3 halves. So when you take the 2 and you multiply it by a half, they will cancel, turn into 1. So you'll be left with negative 3. And then, of course, this is 6 goes into 6 cubed, 6 squared times. So this is 1 over 36 integral tangent to the negative 3 of theta. I'm secant theta, tangent theta, d theta. I mean, there's no calculus in any of this. This is just algebra and trig, knowing your power properties, knowing how to factor properly, knowing how to take numbers to a negative 3 halves power. That's all I'm doing. It's just, complicated. All right, so then this is tangent to the negative 2, right? So that would be secant of theta, and then it's our choice. We can write it as tangent to the negative 2 theta d theta. You could also write it as 1 over tangent squared. That would be fine. All right, so now let's rewrite this. So, I mean, we're basically looking for some way to figure this out. So, I mean, we could leave it as secant theta, and then we could write, well, actually, I know what I could do. I could change this into 1 over cosine, right? Because secant is 1 divided by cosine of theta. That's the secant identity. I could do that. And then tangent is sine over cosine, right? So then I could write that as sine over cosine. And that's the tangent identity. Right? If all else fails with trigonometry, you always turn everything into sines and cosines and see what falls out, right? This will work. So then this is the integral of 1 over cosine. And then, of course, the negative 2 means those ones over there are going to flip. So it's going to end up being cosine squared theta divided by sine squared theta. Or if you like, you can just say cosine theta squared over sine theta squared. That's fine too, right? It's the negative power I'm getting rid of right here. So it causes the fraction to flip over and turn into a reciprocal of itself. Sorry, I didn't like how far away my theta was. I'm not sure I made it better. Okay, so then cosine squared over cosine would leave me 1 cosine left over. So this is 1 over 36 integral of, and then I have a cosine of theta over a sine of theta, right? Because in other words, I'm canceling, right? One of these with one of these, right? So that leaves me 1 cosine left over, and then a sine squared theta, d theta. And then if you remember, we learned a trick for these. I mean, if all else fails, try rewriting it as cosine of theta over sine of theta. times 1 over sine of theta. Well, no u sub immediately comes to mind, but I do know that cosine over sine is cotangent of theta, and 1 over sine is cosecant of theta. And at this point, I have a little bell going off in my head because that's an integral that we were supposed to learn in Calc 1. Might not have learned it because it's not used very often, but it's right here. Cosecant cotangent is negative cosecant. It's the equivalent of secant tangent, which we do use more often. But cosecant cotangent is negative cosecant. So that would be number 17 on our sheet. I finally manipulated this enough that I have it on my quick integral sheet. Now keep in mind, that's a ton of work. And none of it's really trig substitution, right? The trig substitution just gets us to the trig. All the rest of this is just brute force, trig identity, right? Trying to find a way. Oh, and it's negative because of the formula. Right? So to get to that piece, right? I did my trig substitution right here. I mean, that's this section. But all the rest of this is previous stuff. Learning how to FOIL, learning how to factor, learning how to distribute, doing tons and tons of trig identities, Pythagorean identity, secant identity, tangent identity, then cosecant and cotangent identities. That's right here. So that's the cotangent identity. That's the cosecant identity. You're just playing around until you get somewhere good, until you get to some kind of formula that you already know. Now, we cannot leave it with theta. That's no good to us. We need to have a substitution at the very end of what this was. And for that, we should go back to our lovely triangle. Cosecant is 1 divided by the sine. So if sine of theta is opposite over hypotenuse, cosecant of theta is hypotenuse over opposite. So let's make that comment. So cosecant of theta is hypotenuse over opposite. Right? It's the reciprocal of the sine. And so it would be the hypotenuse, which is x, divided by the opposite, which is the square root of x squared minus 36. So that's what we put in. So that would be negative 1 over 36. And then this would be x over the square root of x squared minus 36. I guess I could merge those together here. We're going to make one fraction out of all of this. I'll make it negative, and then I'll just extend this and put a 36 in front. There you go. Now it's one fraction. And then plus c. There you have it. Now it's technically not rationalized. If you want to rationalize it for whatever reason, you know, just because you feel like it. Oh, and for the record, this was the third substitution we made, right? So that's right here. Right? We back substituted. We substituted back what we were, the variable we were working with, which is x. But if you want to, you could multiply this by the square root of x squared minus 36 over the square root of x squared minus 36, if you feel like it. And it would get you that it's x square root of x squared minus 36 over just x squared minus 36. So if you wanted, you could write it that way as well. So you could say it's negative x square root x squared minus 36 over 36 times x squared minus 36 plus c. Again, if rationalization really strikes your fancy, knock yourself out.